Chapter 4, Section 1, Identifying Linear Functions, Lesson 1, Video 1 of 3 videos, Identifying a Linear Function by its Graph. The example says, identify whether each graph represents a function, explain. If the graph does represent a function, is the function linear? So the first part is whether or not each of these 3 pictures or 3 graphs are a function or represent a function. So the key to checking for a function is whether or not it passes the vertical line test. So if we look at A and we draw some vertical lines going through our graph, you'll notice that they only cross once. Therefore, the first one is a function. Again, go to B and do the same thing. And every time you draw a vertical line, you can tell again that it crosses just once. Therefore, this one is also a function. And then last but not least, you'll notice that the last one is a vertical line. Because it is a vertical line, it is not a function. The next step is to determine whether or not each of these items are or are not linear. For it to be linear, it needs to have a very specific diagonal line look. A vertical line is technically linear, but since it's not a function, it's not a linear function. This does have a linear equation to it. It just simply has no slope, which is why it's not considered linear. So C would be considered not linear, but by definition of a straight line, it is a straight line. B makes a U shape, so it is not linear. And the first one is linear. So again, specifically C, just to make sure you understand, C is not a linear function. It is by definition a linear equation though. It would be x is equal to 3 in this case based on what the graph is. So it is considered linear, but just it's not a function. It definitely does not pass the vertical line test because it is a vertical line. And then a U shape is a quadratic, so an x squared, therefore that one would also not be considered a linear function. And then A is an example of a linear function. So the U tries the same thing, so you need to identify whether each graph represents a function, and then if the graph does represent a function, is that function linear or not? And that is the end of the first of 3 videos.